Hello, academic stars around the globe. Welcome to Caltex Academy. SNA, my name is Julius, and thank you for joining us today. On our board, we are looking at trigonometric ratios in Cartesian plane. So today I'm going to teach you how to identify acute angles from Cartesian plane and how to effectively use it to calculate ratios like cosine, sine, and tangent. So from here, we know that there are different types of angle. One is the acute angle, an angle less than 90, and we have right angle, an angle which is exactly 90 degrees, and we have obtuse angle, an angle that is greater than 90 degrees, and we have also reflex angle, an angle more than 180 degrees. But we have to know that while dealing with these trigonometric ratios, we always use an acute angle. So we have 4 quadrants, and here we need to be able to locate acute angle in each of these 4 quadrants. Let's take a look at the first quadrant. Here we have an angle theta subtended at the center. We can call this one as center O. And here we have a point at this circle. Now this point is having 2 coordinates, x coordinate and y coordinate. Now when you look at from here, from the origin, following this direction of x, we have the distance here x, which is equivalent to what we have here, and y also along the y direction, we have it here. So that is when all the angles are positive for sine, cosine, and tangent. Now, let us take a look at the second quadrant here by us extending this same line here as a result of reflection along y-axis. So if we take this one and we call this point to be point Q, with now coordinate of the x-axis here will be negative, and for us to get this negative, we also need to trace it downward here, and we have to mark it from here perpendicular, meeting this at right angle. The distance from here up to there is our x, but this time we have a negative x here, and this is y. So therefore, the coordinates here is negative x, comma, and y. Now, we still have our angle here, theta. But remember, our r as the radius is a fixed distance from the center to the point here at the circumference of the cycle. Always the value for r is positive. So that is one thing we have to also mark. Now let us move on and also locate this same point here. This time we're going to reflect it through the x-axis. So we can do so by maybe getting again our dotted line and catching up from here, and then we can move on and let us also subtend the same length here. And this one meets at theta. So our angle theta is here, and this is also at 90 degrees. We have 90 degrees, that, and let's call this point R. And the coordinate this time we share the same x here, negative, and this one also is negative y. So the coordinate we have here is negative x and negative y. So that is one thing. And lastly, let's move on to the fourth quadrant and also do the same. We can go on and subtend this to touch at this point. And again, here is meeting at 90 degrees. Therefore, when we join this one here, we also have the same radius as before. And our R is this one, and we can call this one as point S. We have negative y, and we will have the positive x and negative y. So this is how we can locate in order for us to get acute angles. So with all this, let us move on and see how we can get sine, cosine, and tangent of these angles using the Cartesian plane. So taking one of these quadrants, and that is the first quadrant here, we can have sine of this angle theta is given by opposite, and our opposite here is y over hypotenuse r. Also, we know that 1 over sine theta is the same as cosec theta. Now, if that is the case, we also need to get an expression for cosec theta here. Now, 1 over means an inverse of this sine theta. So therefore, the inverse is like interchanging the numerator and denominator. Therefore, cosec is the same as r over y. So again, let's move to the next one here, and that is cos of an angle theta is given by adjacent, and our adjacent is x over hypotenuse r. Again, if we divide 1 over cos theta, this is equivalent to sec theta. And if that is the case, then we'll have here sec theta is the same as the inverse of cos, and the inverse here is r over x. So let's move on to the last one, and that is tan theta. So tan theta is given by opposite over adjacent. So our opposite is y, adjacent is x. When we also divide 1 over tan of an angle theta, we get cot theta. So likewise, we can reverse this, and we have cot theta is the same as x over y. Therefore, these are the 6 important trig ratios that we can also remember and can get in any question. So let's move on and look at the cast diagram. Yeah, so this is the cast diagram. Why do you call it a cast diagram? You know, we have 4 quadrants here with those letters C, A, S, T. We're taking from this direction like that, and we know in mathematics anti-clockwise direction is positive, and that's why we're moving in this direction like that. So when you spell this, CAST is has a diagram. Now, why are we interested in this has diagram? There are some questions that are necessary for you to know this has diagram. Now, what is the meaning of this A? The meaning of A here is all the 3 basic trigonometric ratios of sine or any angle, let me say theta, cos of any angle, also theta, and tan of any angle theta, all are what? Positive. If you get a calculator and you punch in any angle less than 90 for sine, cosine, and tangent, you will get your answers as positive results. So let's move on to the next one. Here, this one is only sine, that is positive. So sine of any angle theta, for this case, is positive. But for cos of the same angle theta and tan of the same angle theta is always negative in the second quadrant. Here, this is tan of any angle theta in the third quadrant is always positive. But sine of the same angle theta and cos of the same angle theta is always negative in the third quadrant. So lastly, we have here cos as a positive and sine theta plus cos theta are always negative in the fourth quadrant. So you can go on and get a calculator and get any angle more than 270 degrees. You realize that a sine or cosine of that angle gives you a negative results. Meanwhile, cosine of that same angle will give you a positive results. So that is what is meant by cast diagram. In our next lesson, we'll look at questions that require us to identify the angle in these different diagrams. As we move from this direction, we start from 0, we go to 90 degrees, we move on to 180 degrees, here to 70, and back to this 0 degrees, we have 360. That is after complete revolution. So if you have watched to this time and you have not subscribed to the channel, do me a small favor, subscribe to the channel, like this video and share with your friends, and see you in the next video where we shall discuss some examples related to what we have done in this video. See you on the other side. Peace out.